Hey there, scientists. Today, we are talking about the atmosphere and landforms, and you are going to be able to explain how processes in Earth's atmosphere interact with and change the shape of landforms. I want you to think back to what you remember about Earth's atmosphere and what you have learned about how Earth's atmosphere interacts with Earth's other major systems. You might want to go back and look at some of those other lessons we've done to remind yourself, but the atmosphere is a thin layer of gases that surround Earth. Winds and storms take place in the atmosphere. Winds move sediments across Earth's surface, creating landforms. Winds blow across lakes and the ocean, affecting weather patterns and climate. So today, what we're looking at is these really interesting landforms right here. And over time, rain will dissolve the rock until these Tufa Towers are no longer exposed above the lake's surface. So these rocks, these interesting structures, are called Tufa Towers. And what we're talking about is the atmosphere and landforms. So remember that both air and water can interact with landforms and change their shapes. And today we're talking about the atmosphere and landforms. So could you predict how you think the atmosphere might affect the shapes of these landforms? Yeah, it's possible the wind could blow on them and crack them off. It's possible that rain could, erode them or wash them away. There's a lot of possibilities of what could happen when the atmosphere and these landforms interact. As we read this, we're going to read in order to describe how the processes in Earth's atmosphere interact with and change the shape of landforms. What are these strange-looking rock spires? These formations are Tufa Towers in Mono Lake, California. Tufa Towers contain calcium carbonate, a chemical found in limestone. Tufa Towers form underwater. If the water level in the lake drops, the Tufa Towers are exposed to the atmosphere. Then winds and rain begin to weather the towers. Strong winds that carry sediments act like sandpaper, grinding down the surface of the rocks until they eventually become smooth. Rain weathers rocks and sediments, eventually wearing down hills and even tall mountains. Rain is naturally acidic. Chemical pollution can make rain even more acidic. The acid rain can dissolve the limestone rocks that make up the towers. The dissolved calcium carbonate runs back into the lake. Remember, weathering is a process that takes place when rocks are broken into smaller pieces. Forces on Earth, such as wind-blown sediment and moving water, can cause weathering. Weathering can also occur by chemical processes. What process takes place when winds blow sediments to the rock towers? When wind blows sediment to the rock towers, the sediments cause weathering of the towers. The sediments blow into the towers and grind them away like sandpaper. Strong winds, right here in my text, strong winds that carry sediments act like sandpaper, grinding down the surface of the rocks until they eventually become smooth. So, what causes chemical weathering of the Tufa Towers? Chemical pollution can make rain even more acidic. The acid in rain can dissolve the limestone rocks that make up the towers. The dissolved calcium carbonate runs back into the lake. So I can look back at my text and I can learn that acid rain could cause chemical weathering and erode these towers. How does acid rain cause changes in the shape of the Tufa Towers? The chemicals in the acid rain dissolve the limestone that makes up the rock towers. So let's summarize how the atmosphere is responsible for the weathering of the Tufa Towers shown here. So we can explain that winds, or moving air, of the atmosphere carry sediments that weather the towers, and acid in rain that falls from clouds through the atmosphere dissolves the towers. Try to explain how the geosphere and hydrosphere are also involved in weathering of these towers. You're right, the sediments the wind carries are part of the geosphere. The rain that weathers the towers is part of the hydrosphere. So these Tufa Towers are being affected by all four parts of the sphere, of our Earth's spheres. As you move forward, you are going to be asked to list 2 factors in the atmosphere that can change the shape of the landforms, and you are going to be asked to predict if the amount of acid rain increases, how might the organisms living in the lake be affected? So you're going to have to list and predict, because your goal with this lesson is that you can explain how processes in Earth's atmosphere interact with and change the shape of landforms. Good luck, scientists.